In this video, we're going to review the transformations of linear functions. Now, the base format for a linear function is f of x equaling a times x minus h plus k. Now, we have a couple translations here. We got dilations, and there could be also reflections. So we'll go through each one of those, and then we'll get to some examples. So they're asking you for translations. Translations means slides, so movement from side to side or up and down. So you have a horizontal translation when the line is moved from right to left, or it moves the line from right to left. And when that happens, you look at the h in our formula. Now, if h is negative, you go to the left. If h is positive, then that goes to the right. Now this can be confusing because in the base formula has x minus h. That minus sign does not dictate what h is. Okay, so for this one, if I have x minus 4, my h is actually 4. Because here's my x, here's my minus sign, and then my h is 4. So this would mean it goes to the right 4. And if I had x plus 4, this is the same thing as saying x minus a negative 4. Because a minus 4, negative 4 means I'm really adding 4. So my h here is a negative 4, which means I would go left 4. Now the vertical translation means moving up and down. So that's our k. So this one is our k here. If k is positive, it goes up. If it says minus k, then it goes down. Dilations is referring to our a in the formula. So our a is located here. It could be on the inside of the parentheses or it can be on the outside of the parentheses. So if it's on the outside of the parentheses, we would call that a vertical dilation. And for a vertical dilation, it could be described as being a vertical stretch or a vertical compression. For a vertical stretch, the a is going to be bigger than 1. So if you take the absolute value of that number, of whatever a is, it's going to be bigger than 1. And if I take the absolute value of a and it's between 0 and 1, that means it's going to be a fraction or a decimal between 0 and 1, then that would be a compression, a vertical compression. Now, if the a is on the inside of the parentheses, we're going to be looking at a horizontal dilation. And a horizontal also has a stretch and compression. So for a horizontal stretch, the absolute value of a is going to be between 0 and 1. And a horizontal compression is going to be, the horizontal compression for a is going to be bigger than 1. So the horizontal stretch is going to be it's going to look the same as a vertical compression. And a horizontal compression is going to look like a vertical stretch. Okay, so if you know one of them, so if you know all the ones for vertical stretch and vertical compression, think of the opposite for horizontal stretch and horizontal compression. And the last part is talking about reflections. The reflection is referring to the negative. And the negative is going to be in front of the A. So if the negative is on the inside of the parentheses, that means the A is on the inside of the parentheses. So if the negative is on the inside of the parentheses, it's going to be affecting the x-axis, the x-coordinate, which means that's going to go across the y-axis. And if the negative is on the outside of the parentheses, that means the last thing you're going to do is multiply by a negative number. That means it's going to affect the y, and that goes from a positive y value to a negative. So that's going to be across the x-axis. So now let's take a look at some examples here. Here it says describe the transformation of each linear function. So the first thing we're going to do is determine if there's a vertical or a horizontal translation. Here we have both a vertical and a horizontal translation. This 2 right here, this is telling me, so when I have x minus 2, that my h is actually 2. Because remember, I have x minus h plus k, and then the a is right here. So the h is a positive 2. That means it goes to the right 2. And then this minus 8 on here, that's my k. That means it's going to go down 8. Now another way to determine the horizontal translation is if I take whatever's in parentheses, x minus 2, and set it equal to 0, and then solve for x. So that would give me add 2, x equaling plus 2. That tells me it's going to go to the right 2, because the base format would be, or the parent function would be, for a linear function, would be y equals x. So if x is 0, y is going to be 0. If x is 1, y is going to be 1. Second example, I have h of x equaling negative 5/8 x. Now there's no horizontal translation because I don't have an x minus an h or an x plus an h, and there's no vertical translation because there's no k involved. So I do have an a. The a is negative 5/8. So this is telling me that I do have a dilation. It's on the inside of the parentheses. So if it's on the inside, this is a horizontal dilation. And then if I take the absolute value of negative 5/8, the absolute value of negative 5/8 is 5/8. So 5/8, so since this is horizontal, 5/8 is less than 1, which means this is going to be a horizontal stretch, which just means the stretching part is my run, because if I think of my slope, treat this like as a slope of 5/8. It goes up 5 to the right 8. So this means I'm stretching it horizontally to get that long line. So that's a horizontal stretch. And then this negative here means there's a reflection. So reflected over. Now this is affecting, it's on the inside, so it affects the x coordinate. So it goes from a positive x to a negative x, which means that's going to go over the y-axis. And our last one, f of x equaling negative 5 on the outside times x. Again, I don't have any translations. I have a dilation. It's on the outside, so this is vertical. The absolute value of negative 5 is 5. When the a is positive, or when the a is bigger than 1 for a vertical, this would be a vertical stretch. And I do have a negative here. The negative's on the outside, so this is reflected over. The last thing that I'm going to be doing is multiplying by a negative 5, which means it goes from a positive y value to a negative y value. So that goes over the x-axis. So that is how you can describe the transformations of linear functions.